Okay, let f of x equals 3x squared minus 6x plus 2. Find f of 2. Naya, tell us what find f of 2 means. Slow down. Well, just for x. Because it was f of x, now it's f of 2, which means 2 has replaced the x. So they're letting you know you can replace this x with a 2 and this x with a 2, and then you just type it in. Now when you're typing it in, it would be 3 times 2 squared minus 6 times 2 plus 2, and when you do that, you get what? I didn't get 26. 2 is correct. Second quit. Okay, now I want you to turn in your packets. I believe we're still on page 9. Shh, guys, get quiet. Okay, your equation for A was y equals negative, parenthesis, x plus 8 squared plus 1. Is that right? Now, we already wrote down the fact that that made it shift left 8. Whoa, this isn't the right graph then. Sorry, that was from another period. Okay, let me redo them. Okay, so you already graphed it on your graph paper, right? To save time, I'm just going to do it on my calculator and copy the picture here instead of regraphing. So y equals parenthesis, or negative parenthesis, x plus 8, close parenthesis, squared, plus 1. Okay, that's what the graph looks like. Now I'm going to copy and paste it onto the worksheet we're working on. Okay, here we go. There's the graph. What is the domain of that graph? Girls, what's the domain? Hold on, let me do something real quick. Y'all's doesn't really look like this because see how like on this screen you can see all 4 quadrants? I know. And on y'all's, and on the graph that I did on your paper, you can only see quadrant 3. Well, I'm going to zoom in on the graph so that it looks more like this, okay? So give me a second. I can see that only the x-axis on the positive side, it only goes right 3 and it goes up 1. So I'm going to change the window to reflect that by changing the x max to 1 and the y max to 3. And then it looks like it goes a little further than 10 on the y min and the y max. I don't care exactly how far, but I'm just going to change them to both negative 15. That way it zooms in more on the 3rd quadrant like y'all's paper is. Okay. So now that looks more like what you see, right? Okay, so now I'm going to copy and paste that. Some of y'all need to pay attention. The test is Friday. Okay, shh, we don't have time. Here we go. So there's what you see on your graph paper. The domain. Domain deals with x values, which are left and right. If you start at the vertex and you travel left, how far can you go to the left? Forever. And since it's left forever, that's negative infinity. If you start at the vertex at this parabola and you travel to the right, how far can you go? Infinity, because you can go forever to the right. So positive because it's right. For all parabolas that open up or down, like the ones we're doing, this will always be the domain. Always. Okay, if you have a parabola, this will be its domain as long as it opens up or down. In Algebra 2, that will change because you're going to have parabolas that open sideways, left and right. But for now, this is going to always be your domain. Okay? The range changes because the vertex location changes. Okay? Right now, where is this vertex? -8, +1. So, for the range, how far down can you go on the graph? Forever down, so negative infinity. How far up can you go? 1. The y value is 1. Oops, and bracket because it stops there. Now, zeros is just another word for x-intercepts. So how many zeros exist with this parabola? 2. Here's an x-intercept, and here's an x-intercept, and they're located at -7, 0, and -9, 0. Not always. Okay, now, for the y-intercept, you can't really see it on the graph that I have on the screen, but you know that the y-intercept is going to be way down here on the negative y-axis. How can you find it? The table. If you go back to your graph and go to the table by hitting second table, what are you looking for to identify where the y-intercept is? Where? 0 in the x. So right there, and doesn't that look about right? 0, -63, because it would be way down there. So the y-intercept is 0, -63. Okay, interval of increase and decrease we'll come back and do last. Maximum. Does this parabola have a maximum point? Isn't this the highest point the parabola has? So the vertex is the maximum point, -8, +1. We're going to do that last because I'm going to draw on the graph for that, so we'll come back and do it last. Does this parabola have a minimum point? Why not? It continues going lower and lower and lower, so the minimum value does not exist because it goes to -infinity. Okay, we don't have time today. In behavior, this that I'm currently writing will be given to you on the paper, okay? That will be given to you. And then they will want you to fill in the blanks. As x approaches -infinity means what? Give me one word. So left. Okay? Yeah, left is what I was looking for. X approaches -infinity means left. So x approaches +infinity means right. If you leave the vertex and go left, you're also going down. If you leave the vertex and go right, you're going down. So no matter which way you go, left or right, you go down for both. With parabolas, their ends behave in the same way. They either both go up or they both go down, which is why they are even graphs, because their ends behave the same way. Give me an example of a function that would behave in opposite ways. No, like what kind of function? A linear. If the ends behave in opposite ways, like one side goes down, one side goes up, that's opposite directions, and that's what odd would be. Linear functions would be odd. Parabolas behave the same way, so they're even. Okay, now let's talk about intervals of increase and decrease. When you are talking about intervals, you only care about x values. So keep that in mind. That's the hardest part about this, is remembering that we only care about x values. Okay, if you leave this vertex, okay, which way would be increasing? This side or this side? You tell me if I go like this, that's increasing? No. How do we read? We read from left to right, correct? So if we start over here on the left side of the parabola, don't I first have to go up first? So that is increasing. Now, tell me when it started increasing. Do we really know? Why not? It was at infinity, right? And since it's from the left side, it started increasing at -infinity somewhere, left forever ago. And it increased until it got to this point, which has an x value of -8. So it increases from negative infinity until it gets to that vertex at negative 8. Now, if that's where it stops increasing, doesn't that mean it starts decreasing at negative 8 and continues increasing forever to the right, which would be positive infinity? So it increases from negative 8 to positive infinity. No, it's not too hard. Okay, let's go to the next one. Everybody got that copied? Okay. All right, here we go. Your equation was y equals 2 times x minus 6 squared minus 2. Did we do any of this? Not anything, not even graphing? Okay, well, let's graph it first. I can graph some of it without even having the calculator, because we all know now that vertex form is y equals a times x minus h squared plus k. So tell me the a value. Okay, and what all does that a value tell you about this parabola? No, you're right. It's greater than 1, so it's going to be a vertical stretch, and it opens up because it's positive. The only things the a value tell you are whether it's going to open up or down. Positive is up, negative is down. If the a value is larger than 1, it'll be a vertical stretch, which will make the parabola skinnier. If the a value is less than 1, like a fraction, 1/2 or 1/4, then it will be a vertical shrink, which will make the parabola wider. Now, what is the h value? Positive 6. Because remember, the formula is x minus. So that minus is from the formula. That means somebody just plugged in a positive 6 into h. And what will that positive 6 do to the parabola? Right 6. And then what is the k value? Negative 2. And what will that do to the parabola? Down 2. Okay, so I now know to find my vertex of my parabola, I go right 6 units. So 1, 2, 3, 4, 5, 6. And then I go down 2. Now, I could find the rest of my points from graphing it and looking at the table, but I'm going to show you how you could also find 2 more points without graphing it yet. Look at the board. See how the a value is 2? That means your first points are going to be up to each one, right one and up to left one. But if you can't remember that, you can always graph it and look at the table. Those 2 points are also your zeros, aren't they? Because those are your x-intercepts. Now, to find the rest of the points, we need to graph this in the calculator and go to the table. So y equals 2 parenthesis x minus 6 squared minus 2. Oh, and I need to go, see how this graph on your paper is zoomed more into quadrant 1? Okay, but that's what I'm talking about. On your paper, see how it's zoomed into quadrant 1, and on my graph it's zoomed into quadrant 3? So I need to change my window again. So I want to see more of the I need to see more of the x-axis on the right, which is x max. So I'm just going to do it to 15. And then I don't care about seeing as much on the left side of the x-axis because it only goes left 2, so I'll change that to negative 2. And then for the y min, it only goes down 3, so I'll change that number to a negative 3. And the y max, I don't know, I'm not going to count, I'll just put in 15. Now when I graph it, it'll look more like what's on your paper. And now I'm going to copy and paste it onto the worksheet screen. I mean, I feel like if y'all watch me do it enough, you might learn on your own, but I'm not going to spend a lot of time on it. Because I'm pretty sure on the test, you won't need to do it. Okay, so here we go. Pay attention. So that's, oh, never mind. I wasn't doing that. We were graphing it the right way. Sorry. Okay, we're going to the table. Second table. And then when I look over here, I definitely can't plot any of these points because they're too big. 316 I can probably do. So that would be right. 3 up 16. Okay, then I'm not going to be able to plot the y-intercept because it's where? Correct. Look, 0, 70. That's why we can't fit the y-intercept on there because it'd be way up here. But it asks about it, so we need to go ahead and put it right there, 0, 70. Okay, and now I'm going to find one more point on the left side of the parabola. I'll go with, we already did 316, so I need to go down and find another one. What's 4? 4 what? 4, 6? Okay. So if I go right 4, 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. Now, don't you think that I can find the other side of the parabola the same way by just continuing to plot points? Correct. I feel like it's faster just to go ahead and draw in your line of symmetry, which would cut straight down through the y-axis, so right here. And then you just flip the points over the line because parabolas are symmetric to that line of symmetry. So I know that if this point is 1, 2, 3 away on this side, then there'll be another point 3 on the other side. Right? I went too far. Hold on. Okay, and then this point is 2 away from the axis of symmetry. So there's a point 2 away on this side. And then we already have those. Now remember though, if you can't remember to get to your first points, look at A. You could have always found them on the table. There they are, 5, 0, and 7, 0. And then there's your vertex, 6, negative 2. Okay, so now I'm going to finish connecting it, and now I'm going to answer those questions. What is the domain of any parabola that we're doing? Correct. They go left forever and they go right forever. Now, for range, it changes every time according to where the vertex is. How low will this parabola go? Well, but remember, for range, all you care about is the y value, so negative 2 is the lowest. And then how high will it go? Infinity. Zeros is another word for x-intercepts, and there are 2 of those, and they are located at 5, 0, and 7, 0. Okay, now the interval of increase only cares about the x value. So what is the x value of the vertex? 6 is the x value of it, right? That's the x value of the vertex. So didn't it start increasing at 6 and then increase forever to the right? So the interval of increase is 6 to infinity. And then it started decreasing way over here and then went down until you got to that vertex at 6. So the decreasing is negative infinity until it gets to the 6. Yes, Sion? Because it's going, domain is left to right, and this one's going left forever, this one's going right forever. But left is negative, right is positive. You don't get it? I mean, yeah, they're not both positive because we don't care about up right now. We care about domain, which is left and right. And this one's going left as it's going up, which is negative. Because think about it. Eventually, as this one continues to travel up, isn't it going to eventually cross over into the negative side? So that's why you put a negative on that one. Okay, then for this one, does this parabola have a maximum point? No, because it continues going higher and higher. So the maximum does not exist. Does it have a minimum point? And where is it located? 6, negative 2 is its vertex, and that's also its minimum point. Okay, for end behavior. As x approaches negative infinity, y approaches infinity because it goes up. As x approaches positive infinity, y approaches infinity. They go up on both sides because parabolas behave the same because they're even graphs. Okay, now turn to page 10. Okay, scratch out the equation that was there. I'm about to give you a new one. It's y equals negative 4, parenthesis, x plus 3 squared plus 4. Do what on the test? Well, yeah, but it'll be like one question at a time. Like one question might give you a graph and it might just ask the domain. And then the next question might give you another graph or an equation that you have to graph yourself, and it may ask you the range or the interval of increase. Yeah. Okay, so the first thing I'm going to do is I'm going to go ahead and get my vertex on here and my axis of symmetry before I even use the calculator. What is the A value? Negative 4. Tell me what that will do to the parabola. 4 is greater than 1. It'll be a vertical stretch. And then, okay, you have to think of them as separate things. So the negative makes it go down. The 4 being greater than 1 causes a vertical stretch. I don't know if y'all remembered back in the notes, but it was like if the absolute value of your A was greater than 0, then it will be a vertical stretch. So like even though it's a negative 4, the absolute value of negative 4 is positive 4. You've got to focus on it like it's two different things. Like separate the negative from the 4 and think of it instead of a negative 4 as a negative and a 4. And they do two different things. The negative flips it upside down. The 4 is a number larger than 1, so it's a vertical stretch. Okay, what is the H value? Negative 3. Does everybody understand why H is a negative 3 even though the formula says X plus 3? Raise your hand if you don't, because I will explain it. Everybody knows why it's negative 3. Okay, and since H is a negative 3, how will that shift the vertex? It will move it left 3 because it's negative 3. Okay, what is the K value? 4, and that will move it up 4. So I'm going to leave the origin, and I'm going to go left 3 units, and then I'm going to go up 4 units. Then I'm going to go ahead and draw my line of symmetry through that vertex. Okay, the parabola's going to open down, so just watch, because if you don't watch this, you'll be confused. The next 2 points can be found without the calculator also, because I know if A is negative 4, then to get to my next 2 points, I just go down 1, 2, 3, 4, and then over 1 each way, which I need to do in pink. But if you don't remember to do that by looking at the A, just go to your table and those points will be given to you. Now to find some other points, put in your calculator and go to the table. So y equals negative 4, parenthesis, x plus 3, squared plus 4. Okay, I need to go back to my standard window because I've messed mine up from looking at graphs earlier. To go back to the standard window, I hit zoom 6. Okay, I see that the vertex shifted left 3 and up 4 like we said. It goes down and then it crosses the x-axis at negative 2, 0 and at negative 4, 0. Some other points are, okay, look, I already plotted that one. That's the vertex. You can also tell that that's the vertex because look, the 4 doesn't repeat. Negative 32, negative 32, negative 12, negative 12, 0, 0, 4. That means that's your lowest point, that's your vertex. Or in this case, highest point, sorry. What's the y-intercept of this one? Negative 32, so I'm going to go ahead and write that down because it asks about it down here. 0, negative 32. And then I have some other points at -5, -12, and -1, -12, which go off the graph a little, because if you went -5 down 12, it's going to be 2 units off, and -1, -12 will be 2 units off right there. So now graph your parabola. Why is it so skinny? Because of the 4. 4 is greater than 1, and so it's skinnier because of the stretch. What is the domain? Correct. It goes left forever and it goes right forever. I know it's going down on both sides, but as it's going down on both sides, isn't it also moving out left and right forever? What is the range? First, negative infinity. You always do the negative one first. So down first and then up to how high? 4. The vertex went up 4, and that's the highest it gets. Okay, zeros are x-intercepts, and they occur here, which is -2, 0, and -4, 0. Interval of increase. If you're reading that parabola from left to right, which side is increasing, the left or the right? This side, correct? Is the increasing side? Well, remember, with intervals of increase, we only care about x values. So the x value of this point where it stopped increasing is -3 is the x value of this point, right? But when did it start increasing? Negative infinity. It started increasing at negative infinity, forever left to go, and then it increased till it got up there to the vertex, which was at -3. And then think about it. If that's where it stops increasing, don't you think that's where it's going to start decreasing? And then it increases forever, but to the right, because we only care about x values, so that's positive infinity, because right is positive. Okay, does this parabola have a maximum point? Where is it? -3, 4. And that's the vertex. Does it have a minimum? Yeah, because look, that vertex, to get to it, you go left 3, up 4. So -3, +4. It does not have a minimum because the graph goes down forever. And then for end behavior, as x approaches negative infinity, means left, and as you go left, you also go down forever. As x approaches positive infinity, you also go down forever, and the reason they behave the same is because parabolas are even. Their ends do the same thing. Unlike lines, which would be odd, because they behave in opposite directions. All right, letter D. Scratch out the equation that's there and put this one. Y equals x minus 5 squared minus 1. Okay, for this one, what is the A value? Which tells you what about the parabola? It's not going to do either. It has to be greater than 1 to stretch, less than 1 to shrink, so this one is neither. What else does the A tell you, though? Right, and it's going to go up because it's a positive one, right? Okay, what is the H value? Which will shift the vertex how? Right, 5. And what is the K value? Which will shift it how? Down 1. So I'm going to go ahead and graph the vertex, which moves right 1, 2, 3, 4, 5, and down 1. Then I'll go ahead and draw in my line of symmetry. And now I'm going to find the rest of my points. I can find the first two by knowing the A value is 1. Positive 1 means go up 1 and out each way to find those first two. If you don't remember that, though, it's okay, because when you go to the table, you'll see those points. Now to find some other points, you're going to have to graph it. Y equals parenthesis x minus 5 squared minus 1. Okay, now I'm going to go to the table. I'm going to go down to get into some smaller numbers that will actually fit on the graph. Okay, look at all the repeaters. 15, 15, 8, 8, 3, 3, 0, 0. So that negative 1 is your vertex because it doesn't repeat. 5, negative 1, and we already plotted that. What's the y-intercept for this one? 0, 24, so I'm going to go ahead and write that. Okay, now I need a couple more points on each side, so I'll start with this 1, 15 and 2, 8. 1, 15 would be right 1 up 15. And then 2, 8 would be right 2 up 8. And then there was another point, 3, 3, right 3 up 3. Once you have one side done and you see your line of symmetry, it's easy to do the others. You just reflect them across. So this one's 1, 2, 3 away, 4 away from the line of symmetry. So I'm going to go 4 on this side. And then this one's 1, 2, 3 away. So 3 away on this side. There'll be another one. And then 2 away. So 2 away on this side. Or you can find them all from the table. I just think it's faster once you have one half to do the other half by symmetry. Okay, once you have your picture of your parabola, what's the domain? Correct, because domain is left and right. And as you go up, the parabola is going left forever, and as you go up on this side, it's going right forever. What is the range? The range is down, right. The furthest it goes down on the y is that vertex, which is negative 1 on the y-axis. And then how far up does it go? Infinity. Okay, 0 is just another word for x-intercepts, and we have 2 of them, and where are they located? 4, 0, and 6, 0. Okay, interval of increase. Which side of that parabola is the one that's increasing? The right side. And when did it start increasing? X values. Positive 5. So it started increasing at positive 5 and increased forever to the right. So that's 5 to positive infinity. And so it decreased from forever ago on the left, which is negative infinity, until it got to that point at 5. So negative infinity to 5. Okay, does this parabola have a maximum point? No, does not exist. Does it have a minimum? What is it? 5, negative 1. The vertex is also the minimum. In behavior, as x approaches negative infinity, y approaches positive. Aren't both sides going up? So both of these y's will approach positive infinity. Because parabolas behave the same, they are even. Okay, turn to page 11. Parabolas are even. Linear functions are odd. Okay, these are going to be a little bit easier because you're not having to graph them, so it'll save you some time. What you need to do, though, is go ahead and graph this in your calculator, and you'll have a picture on your screen to look at. So go ahead and type in 2x squared plus 8x plus 1. And the main reason you're putting it on your screen is for the table, because I already have a picture of the screen on my board. Okay, so that's what it should look like. So what is the domain? Negative to positive infinity because it goes left forever and right forever. What is the range? Isn't this the lowest point? And on the y-axis, that's at what number? Okay, well look, if you can't tell from your picture, you go to your table and you look for the number that doesn't repeat. So where is it? Look at the table. Which number doesn't repeat in the y's? -7, look. 1, 1, -5, -5, -2, -7 is your vertex. So this is at -2, -7. So the range goes from -7 and then it goes up forever. I am still teaching. The vertex is -2, -7. And that vertex is a max or a min? A minimum. What would the equation of the axis of symmetry be? What do you have to draw on the axis of symmetry right here to cut the parabola in half? And that is a line cutting through the x-axis at what number? So x equals -2. Okay, the interval of increase and decrease only care about x values. So when did it start increasing? -2, the vertex, and then it increased forever to the right, so infinity. When did it start decreasing? No, it started decreasing a long time ago over here at -infinity, and it decreased until it got to -2. Okay, in behavior, both ends behave how? Positive infinity, because parabolas are even. Okay, for this one, number 2, let's do it from my picture. What's the domain? Left forever and right forever, so negative to positive infinity. What's the range? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it goes from -10, and then it goes up forever. The vertex, we now know that the y value of the vertex is -10 because I just counted it out. The x value of it is 1, 2, 3, 4. Is that vertex a max or a min? A minimum. If your vertex is 4, -10, the axis of symmetry would cut through the x-axis where? At 4, so x equals 4. Okay, the interval of increase. Look at the board. Doesn't it start increasing here and increase forever that way? So that's from 4 to infinity. Correct. And then over here it's decreasing, but we don't know when it started decreasing because it was way up here on the left, which is -infinity, until it got to that vertex at 4. And then both ends are behaving how? They're both going up, so positive because it's an even graph. Okay, now I'll turn to the next page so I can do one more with you, and that way you'll know how to do the homework. Okay, you do not need a calculator to do this homework. I'm going to show you how you can do it by hand. These are given to you in vertex form, so you can just quickly do a little sketch over here. What does the x minus 2 do to the parabola? It moves right. Guys, the front number is stretch or shrink. This number is right or left. That's right 2. And then this number is up or down. That's up 5. No. Remember. So now the vertex is right 2, up 5. And will the parabola open up or down? Up, because it's positive 3. That is now enough information to answer every question over there. Because the vertex is at 2, 5. It opens up. You'll know where to draw on the axis of symmetry. So does that make sense how you can answer these without a calculator? As long as you know the directions, which we've been doing for days. Okay, you may switch out, do those 3 for homework.